Thank you, sir. Good morning. Thank you all for coming and sitting in my room. I never expect people to come to an infrastructure as code talk at a developer conference. Very interesting. So this is a talk called The Rise and Potential Fall of Infrastructure as Code. Anybody use infrastructure as code? Some people. Okay, great. Okay, we'll talk about it in a little bit. Okay, so my name is Paul Stack. I used to work at a small company called HashiCorp. Then I worked at a small company called Pulumi. I did some other stuff in the middle. I rage quit a couple of companies. And now I'm like building something brand new. Okay, so I'm like I'm going to say I'm a reformed infrastructure person. I'm not a project manager or a product owner. Don't hold that against me. I still actually write code, so I care a lot. You can find me somewhere on the internet if you want to talk about this, or just come and talk to me at the end. So, infrastructure as code is not a new concept, okay? Infrastructure as code has actually been in the industry, or the evolution, or the origin of infrastructure as code since 1993, okay? Even though I look 80, okay, I was not in the industry in 1993. So I could never fathom that people were trying to build these types of tools back then, okay? The origin actually started by a person called Mark Burgess, Professor Mark Burgess. I should give him his correct title, I apologize. Okay, at Oslo University College. Okay, and basically he tried to solve the ability to be able to automate building his infrastructure. Not just the infrastructure, but the reconciliation loop of keeping that infrastructure in check. So, you know, he would say, this infrastructure needs to have these users. It needs to have these applications. It needs to be in this state. And he wrote a tool around that. That tool was called CF Engine. Okay, anyone ever heard of CF Engine? Okay, this is like, CF Engine is still in the ecosystem today. It is known as the OG of infrastructure as code config management tools, okay? And the concepts he designed this were based on declarative configuration. So you declared where you wanted your ecosystem or your infrastructure to be at, and the system brought the infrastructure to be there, okay? You had not to care. You didn't need to know the imperative steps to get there. The system took care of that reconciliation loop for you. It needed to be automated. Okay, he didn't want to have to do anything to happen. It just needed to work. And the last thing is it needed to be self-healing. Okay, if something changed in your infrastructure, the tool needed to change it to bring it back to what it was supposed to be. Now, this was absolutely game-changing. Okay, now, we know we're very lucky in these days in the ecosystem, okay? We have cloud computing. We can spin up a machine in seconds. It's like so fast. In 1993, that did not exist, okay? You needed to order machines. In fact, virtualization wasn't even a huge thing in 1993. So you needed to order physical machines. They took weeks of lead time. You used to have runbooks that were really chunky runbooks to follow procedures to be able to get systems onto those machines. So having a way of being able to automate this was incredible. So then we skip forward into the early 2000s and virtualization really kicked in. Okay, because ordering single machines to do a job was a really, as you can imagine, it was time consuming, it was expensive, it was not repeatable. Machines became a bit snowflakey where they weren't managed. So we needed to be able to do something different. So virtualization and cloud computing started. It only was until the mid-2000s, okay, where the first real new tool, known as the infrastructure as code tools or config management tools, actually kicked in. The first one was Puppet. Anyone know Puppet? Okay, Puppet's a little more well-known, right, these days. And then another one came very shortly afterwards, a couple of years later, called Chef. Anyone know Chef? Okay, so, we started to get into a more competitive environment. There's a really funny story about why those two, happened. My boss is the person who wrote Chef. So I found out a lot more about that whole ecosystem. And then, actually, only 2009 onwards did DevOps become a thing. Okay, DevOps brought infrastructure as code, config management tools to the masses. Please put your hand up if you have never heard the word DevOps. There you go. It is literally everywhere. It is the new agile, okay? Everyone knows DevOps. Everybody tries to achieve DevOps. Everyone's trying to do these different things. So, and it was very much a case of idempotency. So the system needed to be able to work all the time doing the same thing, and it would brought us to a convergence loop, and it created that desired state. DevOps brought everything. This is actually the CNCF, which is the Cloud Native Compute Foundation, or whatever it's called these days. That is their state of tooling in the CNCF as of last month. Okay, that is unbelievable. Absolutely unbelievable. So as DevOps kicked in, the system evolved and the whole thing sort of like got out of hand. Tool explosion, like things were going everywhere. But the evolution basically boils down to we went from manual to automated configuration. We had, we had this huge shift that moves us away from this error-prone process to a much more machine-driven process, which meant that we were able to get the right outcomes, the right speed, everything that went with it. And then, as it kicked in, cloud computing, scalability kicked in. So we were able to, AWS kicked in 2006. 2006, 13 years after the first tool that allowed us to manage our configuration. So, we really hit that hype wave. We really started to be able to move things. And then, of course, as tools started to come out, as processes started to come out, then we were able to integrate like DevOps, continuous delivery, all of these different pieces that come with it. Now, the evolution of our tooling in this ecosystem is kind of weird, okay? And I'll say it's weird because very opinionated, of course. This is where I start going off on a rant, so excuse me. Just, CF Engine, 1993. Declarative DSL, actual real domain-specific language that allowed you to do things. Then, Puppet, still a DSL, 2005. Pretty great. Chef, 2009. Maybe DSLs weren't great. Maybe we want to do things in Ruby. Narrator interjects, we didn't. Ruby's great, not really. So, but it's actually super powerful for what it does. Then 2011, we had a tool called SaltStack. Anyone ever heard of SaltStack? One person. There's a couple of people always in the room. I need to give you people a hug because there's not many people that usually do it or understand it. SaltStack is actually in existence still today, and it's very powerful. It does a lot of cool things. CloudFormation, 2011. Okay, whoever thought that JSON was a great way to be able to declare things? No, just no, like really. Please don't ever write tools that you have to write JSON. That's a bad idea. If ever you have your mind in doing that, just think to yourself, is this a good idea? And it's not, okay? Ansible 2012. When it came out, Ansible, super powerful way of doing things. Terraform didn't come out till 2014. Okay, I think 2015, 2016 is when I started actually working on the Terraform core team, so it was pretty close after that. Then we kind of regressed a little bit in the ecosystem and we created ARM templates. Okay, anybody, Azure people? Anybody write ARM templates? Yeah, we all have a confession sometimes, right? Then Google created their own tool called a Google Deployment Manager. Now, I will be very impressed if anybody in this room has used Google Deployment Manager. Exactly, exactly, okay? I love Google Cloud, okay? I used to tell people, if you're not in Amazon, you're choosing the wrong cloud. That was the worst mistake I ever made because now I realize that different clouds have different powers, okay? So like, for example, EC2 and Amazon is wonderful for compute. If you're on Azure, it's wonderful for platform as a service. And if you're on Google, it's brilliant for Kubernetes, it's brilliant for big data, all these different things. So, I have yet to meet somebody who has actually used Google Deployment Manager in the wild because it's kind of weird. It uses Jinja templates to be able to write the configuration to deploy to the cloud in a reconciliation loop. Strange. Then Pulumi. Anyone heard of Pulumi? A couple of people, okay. Pulumi came out 2018. Very shortly afterwards, could be controversial. The CDK arrived from Amazon. Okay, a very funny story over beers. Just say, can't say it because this talk is being recorded. But the CDK was like a way of being able to declare infrastructure using code for Amazon. Okay, it wasn't just being able to create CloudFormation templates. You could actually have real programming to be able to do it. So look, we went from declarative DSLs and we started getting into the ability to use real languages. I apologize, and I say the word real because all code is language effectively, but you could use modern programming languages to be able to specify your cloud compute. And then Terraform got on board where they took care of the TF CDK, okay, Terraform CDK, which you could actually use a CDK style construct to be able to write your Terraform code. And then we took a massive step back in 2020 because we created Bicep, okay. Anybody use Bicep? I'm sorry. I'm kidding. I'm totally kidding. I'm sorry. I'm kidding. Right, so like the ecosystem sort of trended, and you can see we experimented with languages, and we've kind of not gone too off the beaten track. Every tool sort of sits on the shoulder of the tool before it and has learned lessons and created better outcomes or tried to create better outcomes based on those tools. Okay? Now that doesn't mean that we've solved it. We absolutely have not. But it shows that we're not thinking differently, to quote Apple, okay? Like we haven't gone and solved this in a different way. And if we take a step back and we think about what the aspirations of what we're trying to achieve is, like DevOps created this idea where we used to have teams that were so disconnected from each other, where you had a software team and they just checked code into a source control system, and then the DevOps team would pick that source control up and they would actually deploy that. Okay, and it does still happen in some companies today, believe it or not. And this was the case of, this is what DevOps tried to alleviate. Okay, this is true DevOps. It tried to take away this wall. It tried to make us one team. It tried to allow us to collaborate and work together to create these better outcomes for our customers. Okay, but DevOps has kind of drifted a little bit, and it's become about the tools, and it's become about a lot of different things. And there's a great quote in the DevOps handbook. Okay, DevOps handbook was written by many very interesting people in the DevOps world, and it basically says, imagine a world where product owners, development, QA, IT operations, and InfoSec work together, not only to help each other, but to ensure that the overall organization succeeds. Okay. By working towards a common goal, they enable that fast flow of planned work into production tens, hundreds, thousands times a day. Okay. And that's, whilst doing that, you keep stability, reliability, availability, and security. Okay. That is literally the panacea of what every company in the world wants. Okay, if your company wants to strive for that, it takes a while. It's not something that you can check a box and say that you achieve. You absolutely cannot. I want that world. I want that if I make one single change, it just deploys and goes straight through and I don't have to think about it. Okay, I was out last night and I was actually on a customer call whilst at a bar. Okay, because a customer was trying to achieve this. So, everybody strives that this is what they want. And we actually started creating metrics, and we started measuring how things were actually achieved. Anyone ever heard of the DORA report? Okay, it started off as the state of DevOps, and it kind of came out originally from the nice people at Puppet, and then it kind of evolved into a whole system, and they've actually got data scientists and everything behind it now. It's incredible, absolutely. And it's an annual benchmark study that sort of allows us to be able to understand how successful we are at trying to achieve that goal, that panacea. Okay, it boils down to 4 key metrics. How many times you can deploy, how fast you can deploy, how quickly you can recover from a failure, and how many failures you have. Okay, now you can go, and they genuinely have a DORA quick check, so you can go and you can quickly measure yourself, and it gives you a score out of 10 based on some parameters, and look, lead time, deployment frequency, change fail percentage, and failed deployment recovery time. So there's a whole movement around this. And we can go and we can massage. For me, these are vanity metrics, okay? Like, I mean, how many times a day, that doesn't mean anything. Like, what does a deploy mean? What's in your deploy? Like, is it actually providing user value? All these things. So I went and took this test for my team, and we got 9.9 out of 10. And it's like, well, yeah, is that actually really the case? What happens if it's a real bug? Then it's a longer lead time and stuff. So, you can massage these as much as you want. But it's very much a case of, we've created this industry to fabricate what we're trying to achieve. We've created these tools, we've created all of these processes, but we're still trying to get back to satisfying the customer in the fastest possible way. Okay, this is where infrastructure as code kicked in. Now, I would like to say that infrastructure as code is awesome. I would like to say that. But for the most, things get very, very, very flaky. Okay, I've spent an extraordinary amount of time of my career building infrastructure as code tools, building things in this ecosystem, and I see the same errors happening, not just in the tools, but also in the people using the tools. Okay, we do not make great tools for developers. We're brilliant at creating tools for end users, but we kind of forget that impact in the middle, that users are actual people that will use the tools that we want. So we don't think of user experiences. But if you think of any infrastructure as code tool that you use today, there's a number of factors that get problematic. One, packages can go out of date really quickly. Okay, so you can check out, I'm not throwing shade on any tool here at all. You can check out an infrastructure as code tool, Terraform, you can pull out any CDK, stuff like that. They're based on a specific point in time, a specific package, a specific version. And if you don't look at that, you don't change that version, and you don't have to change that infrastructure for 6 months, the next time you check that out, that version of Terraform, that version of the CDK, the version of the language under the hood will have changed. Okay? Anybody who says they don't install updates to their machine or languages, they're kind of liars. Okay? And the ecosystem is changing under us all the time. And then, based on that, features are deprecated, features stop working, code syntax changes, like Docker images are no longer available, all these different things. Docker Hub wants you to pay for things. Somebody's account got built and they don't work there anymore, so they're using an API key that no longer exists. We make these mistakes every single day at our work. Okay? And lots of the interlocking dependencies sort of make us in this situation that a deployment is just a single change at a single time, and we don't think about the pipeline. And I promise you, I haven't solved this either. I had exactly this conversation yesterday with one of the engineers on my team. And they were like, well, we need to go towards having API keys available for our customers. And my response was, not yet, we don't. So immediately, I'm like, not future-proofing my system. I'm thinking of something at a point in time, like a time-boxed feature, because I'm trying to deliver value for the customer, but not thinking through in the correct way that if we designed the feature a little better, we would get API keys later in the time. So, we make these mistakes not just in the code, not just in our applications, but definitely in our infrastructure, our security, all of these different pieces. Anybody ever tell you that infrastructure as code is self-documenting? It's like one of the worst sales pitches of infrastructure as code. It's not self-documented. Okay? Now, I rant a lot at this point, so I apologize, okay? When I started working at HashiCorp, there was no conditionals, there was no if statements, there was no loops, there was none of that in Terraform. Okay? And I actually remember being on a call, and the team were like, we're never putting that in. We don't need it. People need to do it. They can do it in a different way. They can template. They can create things over the top. Okay. If you look at some modern Terraform, it is a nightmare. It is really difficult to read, to understand. Not because the team have created a bad job. They've actually created something incredibly powerful. But what they've done is they've had to take a feature that people wanted, requested, and build it into a system that was not designed for it. Okay? DSLs are not designed for loops. DSLs are not designed for conditionals. That's not their job. It's about declarative syntax. And you should be able to look at a DSL and look at it and go, yeah, that's pretty easy to understand. I have no clue what so much Terraform does today. Like none. The same with Pulumi. I even was involved in creating, I was at Pulumi before 1.0. I left like 4 years later. I was involved in so much of it. I look at some of the modern Pulumi code now and I'm like, what the is going on? Like, honestly, I just look at it and I don't understand it. So people basically say that it's self-document, and it's not. Self-document means you should be able to look at something and understand what it is. And we've kind of sold ourselves on this in the craftsmanship era of code. We create these small functions. These small functions are easy to understand. They're easy to read. We've tested them and stuff. We try to do the same thing in infrastructure as code tools. It's very difficult to be able to do that. And like after a while, it means that the engineer who reads your code needs to not only understand what the code does, they need to know the level of abstraction, they need to know the cloud that it talks to. They have so many different variables to be able to do things in. Second issue is code for me is not good documentation. It is not. This is a personal opinion. I hate looking at code and trying to understand what it does. That expressive nature of a person trying to put their intent, their thought into a piece of code, their naming conventions, their way of expressing it, their breakdown of individual functions, that is their expressive nature. It doesn't help me. It doesn't mean that I can read their code and be able to digest it easily. And like, there's plenty of things that can make you want to cry when you look at some of the code that you wrote 6 months ago. I mean, I look at some of the code I wrote yesterday, and I'm like, what? What did I do that for? You know, so if you look back at 6 months, a year, all these different things, it's really difficult to understand that intent. Anybody tells you that infrastructure as code prevents mistakes are just plain lying to you. Okay, it does not prevent any mistakes at all. It actually, infrastructure as code, any automated tools that talk to your production system can amplify the mistakes that you make. Okay? I actually heard a story, this is actually a recent story, of somebody running Terraform Destroy. Okay, they thought it was for a local machine. It was their production infrastructure. So halfway through their production infrastructure, they Control-C'd their Terraform deploy, and their state file was all sorts of broken. Their database was in the deconstructing state in the cloud. Their application was offline. It does not prevent mistakes, people. It really doesn't. It's only real prevention methods, it's real procedures that prevent you from making mistakes. Mistakes happen everywhere, and it's okay to make a mistake. We are humans. It is genetically programmed that we will make mistakes. We are not robots. But we need to, of course, do it in the correct way. Anyone tells you that infrastructure as code tools lower your cost are also liars. Because I can go and I can change a variable in my infrastructure as code and spin up a machine in Azure or AWS that costs my company $10,000 a month. Of course, I can put one up there that costs me $5 a month or whatever, but at the same time, it's very easy for me to incur incredibly expensive costs. There's Azure Insights, I believe, is extremely expensive, and it's quite easy to be able to turn on for infrastructure as code tools. The same with AWS VPC flow logs. If you turn it on, you can incur incredible costs. We make it easy to be able to cost ourselves a lot more money. It prevents drift. I mean, wow. Like, you'll only ever prevent drift if you never, ever, 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 ever make any change to any environment that is running today. Okay? Now, let me ask you a question, and think about this logically. If you work at a company where you have a production outage, and it takes you 10 seconds to go to the AWS or Azure console to fix it, or 1 hour to fix it via your infrastructure as code pipeline, tell me truthfully which one you will choose. Straight away, you have created drift in your infrastructure. Your infrastructure as code is no longer the source of truth. The infrastructure itself is the source of truth, and you have created drift. Same thing happens when you log into a machine and you give somebody pseudo permissions, or you put a new SSH key or any of these. It is drift. And drift is difficult to reconcile. That loop becomes really, really, really difficult. Now, obviously, you can go back and you can take that change that you made and retrofit it to your infrastructure as code. But I mean, who really does that? I mean, honestly, I've made so many places where I've done that and not brought it back into my infrastructure as code. And then the next deploy, it rolls out. I'm like, oh, yeah, I forgot about that. Yeah, right? I mean, we've all done it. People laughing, like we've literally done it. And then the last one, which is the holy grail of the infrastructure as code world, it allows us to be able to self-service our infrastructure. What does that even mean? Like, honestly, this is now the rise of platform engineering and being able to create the ability that software engineers can push their changes or build machines that they want within a specified time box or a specified sandbox or whatever into the cloud. All of your infrastructure has been so automated that now you can click a button to be able to do something in the cloud. I mean, all you've done is the team has just created a layer of abstraction. You could do the same thing in your cloud. You've just created a self-service API to be able to do it in the middle. All of the login, alert, and metrics, security policies have all been built in. And I love the idea. I genuinely love what it's trying to achieve, but it's really difficult to do it. It's really, really difficult to do it. You have tools like Backstage, which are great for creating these types of self-service portals. You can create Terraform modules. You can create Pulumi providers. You can do all of these different things, but they're not free. They take a lot of time, a lot of effort, a lot of maintenance to be actually able to get them. So we definitely did it, right? We were so good that we're deploying hundreds of times a day. Nope, absolutely we are not. Now, this is the bell-shaped curve of adoption, and I would love a volunteer to tell me where they believe on this bell-shaped curve of adoption we believe that we are based on the adoption of infrastructure as code. Don't all rush. One person, please. Oh, what was that? I heard something. No, I didn't hear. Okay, so we're actually around here. We're actually at the early majority, halfway up the early majority around the hockey stick. Now, this is my supposition, of course, working with larger customers, larger parts of the enterprise. But we're very lucky. You people right here, you can come to conferences and you can learn a lot of cool stuff. There are a lot of people in the IT ecosystem who don't get a chance to do this. They're chained to their desk. They have to go to the office 5 days a week and they work in a tiny cubicle. We're so lucky for what we actually can do and the fact that you have companies that do this type of thing and allow you to go. All of these companies who work in mainframes, they work in larger enterprises, maybe even IT parts of the organization of big manufacturing companies or stuff like that, they don't get a chance to look at a lot of these things. That's why we're very early on right now in infrastructure as code. And the fact that we're very early on means that there's not even a lot of people using half of the tools that I said. They don't even know that the CNCF exists. Some of them would dream about being able to use the cloud. We're really in a bit of a weird sort of era here. So much of the industry has accelerated away, and then there's a lot of the ecosystem is surrounded from still stuck in their old ways of doing it. But we're now getting to the point where we've hit massive complexities of infrastructure as code. Firstly, there's a massive technical and cultural learning. Okay, at my company, we call this the 200% problem. Okay, so the 200% problem is you need to know the code of the tool that you are using, the layer of abstraction, the API, all these different things. But you also need to know the API of the underlying system that it is talking about. And I'll use Terraform and Pulumi as a perfect example. You got to know those APIs, and then you also got to know the cloud API underneath them. So you got to learn 100% of that and 100% of that to be able to be successful in what you're trying to achieve. It's very difficult to maintain consistency and security using infrastructure as code tools. I mean, you open up Hacker News, you open up Reddit, you open up all these things, and you'll read about a new security vulnerability that somebody has introduced in their cloud, and people have just taken your database. Okay? I've read so many where people are like, we have an Elasticsearch cluster, and that Elasticsearch cluster is wide open to the internet, and people can just go and pull all the documents. Okay? We don't think about security baked in. And this is what I'm saying, is like, infrastructure as code tools are great about allowing us to be able to accelerate or move away, but at the same time, they actually help us like make mistakes faster. They really do. And then the last one is there's a huge operational integration and long-term maintenance of infrastructure as code. I said to you earlier about package versions. If you're using Pulumi and TypeScript, you've got to keep your TypeScript version up to date, okay? You got to keep like your versions of your modules up to date. You got to keep the versions of the cloud packages up to date. There is like you can't just create this and then forget about it and it's always going to work when you go back. That's not really a thing. And we've ended up in this situation right here, where it's like the house that Jack built and you need to change just one tiny little piece of infrastructure and you got to find the right repository, you got to find the right incantation of API keys, you got to do all these different things just to make one small change that's incredibly risky. So like, what does the future hold for us here? Okay. Maybe AI is the right example. And I'm going to show you AI right now in the fact of, and I'm not throwing shade at my former employer in any way, shape, or form, okay? And I can say, this is Pulumi AI. This is actually helping you describe infrastructure. Can you give me an example of how I can deploy a Docker container to AWS hosted on ECS and publicly available? I mean, that's a reasonable question. That's the type of thing we'd want to do. Let's generate the program and let's actually say, and by the way, I've just typed this. I've just made this up in my head, right? So I'm actually interested to see what they come back with. And it's great because it gives us a prompt and it says, wait, what you need is you need an ECS cluster. You need an ECR repository to store your image or your Docker image. You need a task definition, you need a service, and you need a load balancer. Brilliant, okay? So then I read it and I say, look, there's the cluster, there's the repository, that's gonna build my Docker image, it's gonna create a load balancer, it's gonna create a listener, and it actually has a listener. I mean, where is the security requirements? Okay, like where is the use of VPC, the use of private and public subnets, the use of security group rules? I mean, generative AI is brilliant, right? Is it? For infrastructure as code, it's going to give you some answers. By the way, I could go and I could get exactly that same document from the Pulumi documentation. Terraform will give me the same, right? Actually, I can ask it to give me the Terraform. Rewrite this program in Terraform. Let's see what it does. This is actually very cool. I have to give them props for this because you can actually get it in Terraform. But look, the ECR repository. Oh, Jesus Christ. Sorry, I'm a null resource. I'm going to just close that. But again, they've mentioned the security group here. They've given me the security group, but they didn't give me the security group before. You know, so it's very, very, very much a case of it's really difficult to be able to achieve these different pieces. Wait, where is my screen? No. So it's like generative AI is going to take us somewhere, but it's probably not going to get us everywhere. It's great for getting started. It's great for that day zero operations, we call it. But unless you feed it the context of your infrastructure, it's never really going to understand your true infrastructure to be able to make changes based on that. So I don't know. Platform engineering. Holy Lord, where do I go with platform engineering? We created a monster. Okay, we used to have infrastructure as code frameworks which managed like an API for application developers, which allowed us to be able to self-service users. Now we've created this layer of abstraction in the middle where an infrastructure as code framework has an API that sits on top of it, and developers talk to an API, and that API then services the users. Like, all for me, platform engineering has done is just create another layer of confusion in this system. Okay, and I'm not throwing shade at anybody who has implemented this successfully in their organization. I blame Google. I genuinely blame Google for this. Google wrote a book about site reliability engineering, okay, about how they actually solve problems within their organization and how they deploy their systems, okay? And what people did is, by the way, it's a fascinating book. It's a wonderful book. It's great to be able to get the insight into their operations people's minds. But what people did is they go, it works for Google, we're going to do the same thing in our organization. It doesn't work like that. You can't just take somebody else's idea and put it in your org. It's designed for their org. It's designed for their structure. It's designed for how they work, their culture, all of their tools. You have to come up with your own. If you try and shoehorn somebody else's process, somebody else's set of tools, their tool chain, their flow, their pipeline into your organization, it's destined to fail. And in 6 months' time, you'll have these, we got to rewrite it again, okay? Or we got to re-architect this part of the system, okay? This is horseshit. We do this again and again and again in our ecosystem. We don't think about the focus on the end user. We just have to rewrite the same crap because we've taken the tools and the same process all the time. It's really difficult to be able to take that, firefight it, change it, mold it. It doesn't work like that. So I kind of feel that we've hit the cliff of IAC. Or if you haven't yet, you soon will. You really soon will. And that's not to say that if you hit the cliff of IAC, you got to drop it and you got to rewrite everything. Absolutely not. The cliff of IAC for me is a simple test. Okay? They told me when I was starting software engineering, automate everything. Actually, not automate everything. If you do it twice, think about automating it. You do it the third time, then you automate it. Okay? Then we decided to throw everything in GitHub. Okay? Holy Jesus, that was a mistake. That's a whole different talk, okay? But what happens when a specific requirement comes in that you have to change your infrastructure as code, but it takes 10 steps to do it with your existing Terraform configuration, your existing Pulumi configuration? A perfect example, okay? You need to deploy a new version of an application, and you need to do a rolling deploy through all of the instances in your load balancer, okay? Now, that is not an out-of-the-box scenario for most infrastructure as code tools because they are a declarative state, and you tell them, here is the image, or here is the version of my software, deploy it to all of the instances. You can't say, deploy the first half, take it out of the load balancer, run acceptance tests to put it back in the load balancer, then deploy the second half. If it fails, roll it back. Your infrastructure as code tool is not designed to do that complex scenario. What happens if you have to deploy a database change? Your infrastructure as code tool is not designed to take a snapshot to be able to restore that snapshot in the same Terraform run or Pulumi apply. It's not designed to be able to do that. So when you hit these complex scenarios, what do? We bash things, we PowerShell things, we write scripts around our infrastructure as code tools to be able to manage the limitations of infrastructure as code. And it's not because the tools are designed badly, they're not. They're absolutely incredible at what they do. You tell them to go to a state, they will go to that state. They will keep it at that state. But that's not what we do every day. We're continually having to make changes. We're continually having to resize things. We're continually having to make this change that satisfies our users, our criteria. I gave this talk in Zagreb maybe 3 weeks ago, and a guy came up to me at the end of the talk, and he goes, yeah, but I use Terraform. I'm like, awesome. I loved hearing his story on Terraform. He says, but what I wrote salt stack that generates my Terraform. I'm like, what are you even doing? He's like, well, I couldn't get the right syntax with Terraform. So I could get the right syntax with SaltStack. I was able to use the control flow, and it just pumps out the Terraform. So I was like, all right, does anybody change your Terraform? He goes, no. I said, what happens if somebody changes your Terraform? He goes, well, there's a problem. Because you've now created another layer of abstraction in there. And they solved the problem in an incredibly unique way. Like, incredibly unique. He even showed me a demo of it. It looked fantastic, genuinely fantastic. But there's that whole layer. If somebody changes that, then there's a reconciliation loop that doesn't exist. We've kind of hit that cliff. And I honestly believe that if you haven't hit that cliff, you will at some point in the future. And you're going to have to start taking advantage of automated workflows, and you're going to have to start bringing in other tools like as part of your tool chain, all these different things. IAC has made things harder for me. It really has. Because if I have to think about deploying an application to the cloud, or deploying a new application, or a stakeholder in the business comes to me and says, we need to do this, then we got to think, what tool do we use? What cloud do we use? What hosting provider we use? What CI/CD pipeline we use? All of these, you got to answer 20 questions before you even start prototyping something, trying something. Because it's the standard way that you can't do it without using Terraform or Pulumi. It's made it really difficult. And there's like 3 reasons for me why it's made it really difficult. One, those paper cuts I just mentioned about like choosing all of the different tools, all of the things together. 2, collaboration. Collaboration and infrastructure as code tools is miserable. If you say that you pair program with somebody and all you're doing is sitting on a Zoom call watching them type and you're talking to them, that's not really collaboration. Okay, that's like communication more than collaboration. And we've put ourselves in this situation where we've started collaborating via GitHub. Pull requests. I hate pull requests. Honestly, I genuinely hate pull requests. I wish they didn't exist. Like, it's a very difficult medium to communicate, to give intent, to give reasoning. We're opinionated people. Well, I'm more opinionated than most. And like what you do is you look at somebody else's code and go, that's not how I would write it. And then you make suggestions based on that. Okay? You're not thinking about the user intent of what the code actually does. You make things like, there's a spelling mistake in this variable. Who cares? Like, honestly, who genuinely cares? Call your variables A, B, C, and D for all I care. It doesn't really bother me, as long as it satisfies the end user and the end criteria. We've then ended up in a situation where, and I actually genuinely took this screenshot like a couple of weeks ago, installing Terraform as a guide, and it says it takes 9 minutes. 9 fucking minutes to, 9 minutes to install a CLI tool. You know, who uses VS Code? Or any editor? Like, you have to keep your plugins in sync, you have to keep your package versions in sync. It's really difficult to get started. All of these things are impossible to get started. And the last one is the source of truth. Infrastructure as code should not be your source of truth. It really should not, because things can change in your environment. This is a real problem, even in 2021, and you'll still see these today. You will really. Where you've seen that a Terraform plan looks great, and you've done a Terraform apply or a Pulumi apply, and it goes, nope, that's not going to be a thing. This doesn't exist, or something's changed. Same thing happens in Pulumi, by the way. Just saying, not throwing shade at Terraform over Pulumi at all. All of these tools have these same problems. Source of truth is not your infrastructure as code. It is absolutely not your infrastructure as code. Your source of truth should be your infrastructure in the real world. The only way. That's why you end up with state files in Terraform. That's why you have to do commands like Terraform state rm, Terraform state move, refactor in Terraform, refactor in Pulumi is a pain in the ass. It's difficult because they have state, and that state is a point in time. You don't keep that state up to date. Like, yes, Terraform runs a refresh by default, but that doesn't update the Terraform variables in your code file. You still got to remember to do that. Otherwise, it's pointless running a refresh. A very, very, very famous man called Rick Rubin actually says the words, and it's like, these are very poignant to me. Rules direct us to average behaviors. If we're aiming to create works that are exceptional, most rules don't apply. Average is nothing to aspire to. This is incredibly interesting for me because of the fact that I try and embody this statement in what I do, what I'm building, what I'm doing every single day with the team that I work with. And we are completely trying to rewrite all of these rules, okay? I showed you the infrastructure as code pipeline. All the tools are all evolutions of each other. We have gone in a completely different direction. We've literally walked the clock back and gone completely off the scale here. And what we've actually done is we've created what we believe, and I'm not gonna sell you on the tool. It doesn't really matter. It's not the point of the talk, right? We believe that we've created the future of DevOps automation. And the reason I say that is because we've embodied a couple of different things. One, we've created digital twins for infrastructure. Anybody know what a digital twin is? Anyone heard it, right? Incredible, right? So I'll give you an example. You cannot change a variable on a Formula One car and just put it on the track and hope it works. People could die, like literally. Like that is just, infrastructure people won't die, usually, just saying. But it's the case of bringing it into effect that change has causation. Causation has consequences. And those consequences can be very big for your company. They really can. They can cost a lot of money. They can like stop you from doing like customer things. You can have security implications. You can have GDPR implications, all sorts of things. So we're trying to rethink this and like create digital twins. And there's kind of like, there's three elements of a digital twin, okay? There's the simulation, the real world, and then there's data that you sync between. Okay, and I used to say that like the tool we created is kind of like an actor model, okay, but I got told off by purists in language because they were like, well, it's not actually a system actor. But in a nutshell, basically, you tell the system, here is the state of my data, now apply these behaviors to do it. And those behaviors can be a complex set of workflows or a complex set of steps to be able to get you there. So the same thing happens. And what we've actually done is we've created digital twins of your infrastructure. So you have an instance on your local machine or on your cloud-based service, and then you have the real-world resource, and you're syncing the data back and forward. There's no state file. It actually goes off and gets the data from the real world before it does anything, and that real world is brought into your program, and it's even replayed in change sets. We've created, it's the coolest name ever, and it's not actually the real thing. We've created a hypergraph of functions. You would be shocked at how many people are like, is it a hypergraph? What is a hypergraph? Okay. Basically, we've created this huge layer of functions, and functions call functions, call functions, call functions, call functions. So we have nodes and edges in our system, and the Docker image will run functions. It has an output socket, which is a function. The Kubernetes deployment is a function, and it has an input socket that is a function. So if you change something in the Docker image, all of the dependent functions down the list will recalculate and rerun the whole time. It means you can start to be able to do all sorts of cool code and all sorts of cool scenarios as part of it. How do we build it? We didn't use GitHub to host all of your infrastructure as code. It's actually all in data. When I say data, I mean like it is literally using nodes and edges and graphs to be able to calculate and understand how we put together these complex things. Okay? We made it reactive, so when you change one thing, it understands all of the things that it needs to touch, and it will recalculate them the whole way down. And then, why is it a better model? It's intuitive. You know, it's living architecture. You're actually designing it, drag and drop, working together, collaborating, and it's multiplayer. It's powerful because you can connect nodes and edges. It's very, very around this. Now, I'm not going to show you the tool because this is not the point of the talk. The point of the talk is to remember three things, right? DevOps was designed to focus on delivery. If you spend all of your time looking at your tools and looking at your deployment pipelines and things like that, you're not delivering for your customers. The current tooling doesn't really deliver on these promises. The DORA report actually says if you deploy once per day now, you are elite. In 2005 or 2006, Flickr gave a talk that they were deploying code 10 times a day. Okay, we're nearly 20 years later, and we're saying we're now elite if we can deploy once per day. That feels like a bit of a step back to me. And then lastly, we need to reimagine how DevOps actually works. We need to facilitate that collaboration. We need to bring people together to satisfy our end users. We need to understand the real-time implication of our changes, and we need to be extensible, really extensible. A great way of thinking about this, a very smart person I follow on Twitter called Chris Reed, he wrote a quote like a long time ago. He says, "Until your pretty code is in production, making money, you've just wasted your time." I love it. I remember that I quote it all the time to people. And we also need to remember, we're trying to get to this. We're trying to get this multiple times per day, fast, stable, available, security. And if we want to get to that world, we have to challenge these beliefs. We have to break these rules that we've currently created for ourselves. We've got to break away from through traditional tooling. We've got to think about how we actually deliver things. You can think outside the box. You absolutely can. Thank you so much. I really appreciate your time. I know it's lunchtime, so please go and enjoy it. You can have a look at some of the stuff we've done if you really want to, or if you're interested in seeing a bit more, come and talk to me. I promise I don't bite. So thank you all so much. Have a great conference.